So hi everybody. So I'm Idit and I'm from EMC. In EMC I'm a CTO of the cloud team. But besides that, I have two people that I took from this team. And we're doing advanced development project. And that's one of the projects that we did. So what I'm going to talk right now is about the motivation to this project, why we did it, what is, teach you a little bit about what is Unikernel, why do we think that that's the future, and so on. And then I will talk to you about what we did. So this is the stack that today when you're running, usually that's what you're running. You're running the hardware because you need to run it on something. You're running usually hypervisor, specifically if you're running, most of the people running hypervisor, you can run it on bare metal, but most of them running hypervisor. And in the hypervisor, you have drivers that basically talking to this hardware. Then on top of it, you need a guest OS, right? So you're putting some guest OS or Ubuntu or whatever you feel like. And usually in the guest, not usually, always in the guest OS, you have drivers to basically talk to the mimic hardware of the hypervisor. Then you have the OS kernel, which is the OS kernel, right? And then also you have the OS user processes, which is separate the processes that running on the machine. And then you have the Docker runtime. That is usually people using it, and it's kind of like a very good deployment tool, but it's basically doing the same thing. It's separating your processes. And then in the Docker, you're putting the shell libraries, the language runtime, the application, and the application config. All of this huge stack. And what are we really trying to do? We're trying to run single application with a single user on a single server. And this is kind of like an overkill. And there is a lot of redundancy in this stack. For instance, if you're looking at isolation, we isolate it on the hardware layer, which is physical isolation. We're isolating it on the hypervisor, the guest OS. Then we're separating the processes, again, isolation. And then the Docker, doing the same thing, separate. And then the application level is also separate between the user. And the reason the kernel itself is so complex is because it's basically that's what it's trying to do, right? So back on the day, we were buying this huge mainframe computer, right? That was so expensive, right? We couldn't afford by running one application on this mainframe. Therefore, we needed to share, right? This is what's called timeshare. And we needed to make sure that it's safe to share. I want to make sure that if I'm sharing my computer with the guy next to me, that his application is not talking to my memory and it's not messing up with my machine and with my application. And therefore, the Linux kernel is coming, and their job is exactly to separate. But that makes a lot of sense in the 50 and 60. The question is that it makes sense today. And I will argue that not. And in order to achieve this model, we did a lot of stuff like permission check and rings in the operating system. And you need to make sure that there is multi-address space, that someone will not write to my space, to my memory. And again, make a lot of sense on the 5060. Doesn't really make sense right now, but we're still going to do that. We're still doing it. If you're looking at the kernel itself, there is also a lot of junk in the kernel. For instance, today when I'm running my laptop, I'm running a floppy driver. I don't know who's using the floppy driver anymore, probably no one. You still have it on your laptop. Same thing, USB. You're running on the cloud, Amazon machine. Again, you cannot go to the machine. You still have the bit and the byte of the floppy driver. And this is also security not really safe. Because one of the biggest penetration that was recently was that someone managed to actually go and mimicking the floppy driver and start basically overflow the hypervisor who died and kill all the applications. So it's not really safe, right? And then the last thing is that when you're doing the update, you want to update your machine or you want to do some, download some application, you're doing yum install or you're doing get up, you're getting, again, a lot of junk to your machine. You don't know what you're getting. Some of them is not even running. They're still taking space on your machine. And in terms of security, when there is so much junk in your machine, there's also the surface of attack is huge, which means that me as a hacker can just think about so many creative ways to go to your machine. This is like, it's exactly like if you're looking at this, it's like you're buying a big house with doors and windows, and then you're putting a little lock. I mean, people can still penetrate. But if you're taking a room with no door and no windows, it will be harder. So that's what kind of Unikernel is trying to do. When you're looking at microservices architecture, Docker and Rocket and all of this, there is a lot of sharing that's being done. You're sharing the kernel, you're sharing the memory, you're sharing the file system, you're sharing the hardware. And the only thing, again, that we're doing is we're trying to separate with C group, which is a lock, right? It's not, you can still be creative and penetrate it. This is the Linux kernel language that one need to know in order to maintain the Linux kernel. It's going on and on, right? I mean, there's so much technology there that someone needs to know, and I will argue that there's not a lot of people who actually understand what's going, all of this, all the Linux kernel, kind of like, to maintain that. It's very hard to reason about. Not everybody can contribute. It's really, really hard. If you're looking at source of line of code, just that we will get this is the way I define it. Usually a small application, it's 10K line of code. If you're looking at medium one, it's around 100K. If you're looking at a big, huge application that a team is kind of like maintaining and saving, it's 1 million. This is today the Linux kernel. It's actually probably bigger today. But today, the Linux kernel is 22 million lines of code. It's only the kernel. There's not, you cannot run only the kernel on your machine. And only the kernel itself is 22 million lines of code. If you're looking at Debian, which is, the Ubuntu distro, for instance, 419 million lines of code. I mean, think about how many code and how complicated it is to maintain that and so on. So how did we get there, right? I just described you why everything that we're doing today, it's very complicated and unnecessary. And the question is, how did we get there? And I believe that it's evolution, right? We started with the mainframe, went all the way to the personal computer, all the way to today, Internet of Things devices, and guess what? Unix is the one who actually was there all the time, right? He's the one that went into all this January with us. So what can Linux run on? Anything. What can run on Linux? Anything, right? I can take right now the last distro of Debian and take a Pentium 1 10 years ago, and you know what? It's just not going to work. I don't need to do anything. It's just going to work. So basically what we did as a community, we make a decision. We make a trade-off. We decided that it's more important for us to basically save compatibility, right? To support compatibility versus efficiency. Right? So this is what we decided. It's more important for us to run on Pentium 1 than actually make it, dedicated to what we need for today. So we make it work because it is working, right? We are running it, we're running data center and so on. But now we should, for my opinion, it would be very good if we can make it even right in terms of architecture, and then even maybe faster, right? Then we can get better performance. So, okay, but how, right? What can we do in order to make it better? Should we rewrite the Linux distro? Does it make sense to write one from scratch? Probably not, because it's too much work. Or is it? And I argue that we should think different. And this is a quote from Linus, the guy who wrote the Linux kernel. So that argument was actually about the monolithic versus a microkernel architecture of the kernel itself. So ignore the top side. But what I want you to take from this quote is that what Linux said is that he took, right, he said, except of a tiny kernel that can be rewrite totally from scratch in less than having 1 year of any experience. Basically, that's what he did. He didn't have any knowledge, and in 1 year, he wrote the Linux operating system. So that's exactly what the Unikernel ecosystem did. They understand that what we have today is interesting and working, but it's not really, really efficient. And what they did, they went and created a Unikernel ecosystem. So let's understand what is Unikernel. So today, when you're running your stack, you're running your kernel always. You're running all those libraries, OS libraries on top of it, and you're running your application on top of it. Now, no matter what your application is doing, no matter how much application you're running, you always have all this stuff on your operating system. What Unikernel is doing, they said, let's start from top. Let's start from the application and take only what the application really needs in order to run. If it doesn't need the floppy driver, guess what? It's not going to be there. If it doesn't need all the lib TLC, it's not going to be there. Only what it's need. And it looks something like that, right? So the white spaces that need for this application, they're wrapping it very nicely with some little schedule that's not even smart, and a little bit memory management, and wrap it as basically a bootable image. So that's a little bit more details, and I don't know the audience, so I will talk, and if I don't have to understand everything, but basically this is more like what really happening in the Unikernel. So it's based on library OS, which means that everything is a library. Okay, it contains only what it needs. It's a single address space, and the reason is because Unikernel running only one process. Okay, if it's running one process, suddenly all these layers in the operating system that need to protect doesn't need to protect anymore. Running one user, one process. All the time when we actually protecting is that because if I'm running one process and another guy run the other process and my process is going down, I want to make sure that not all the hosts will go down and then basically cause the process to not work. But if I'm running one process, if it's not going to work, it's not going to work. The host can go down. I don't care. The application is not working anyway, right? So single process, as we said. So if you have an application that's forking, it's a problem. It's not going to work, but multi-threading will work. And no virtual memory isolation. Again, because there's nothing to, basically you're running on ring 0 always. Because again, there's nothing to worry. I don't need to separate my address to, you can write here, but you cannot write here because, it's your machine. Run whenever you want. You will hurt something, you will hurt yourself. No content switch, again, because there is no rings. So you're not doing content switch, and no user more kernel mode, again, no ring. One process, one user. There's no, there's no worry. So how do you do that? How are you building Unikernel? So it's actually not that difficult. You need to take your application binary, your application config, your application dependency. You're taking the drivers, either the physical one or the virtual one, and the language runtime, and you're putting all of this in kind of like a magic packaging tool, and the result is Unikernel. So let's kind of like understand exactly how we're doing it. So in the end of the day, what I said is that what the result is a bootable image. And the bootable image can run on bare metal, but to be fair, it's not really makes sense. And the reason is because it's so small, right? Because I just took everything that I don't need, and I can seriously run a website, which is, I will show you an example, 56 meg, for instance. For a website, for all the machine, everything that's running, 56 meg. And therefore, to take a physical machine and to dedicate all the resources to it, usually doesn't make any sense. So you probably will run on something like hypervisor. So you run on an hypervisor, it's a VM to everything. So you're getting the performance, and we will talk about it in a second, but you're getting the performance and the security of VM and the maturity of VM, because you can do vMotion and you can do whatever, all the tools that you like and use, but you're getting the performance of container. And you're getting a fast boot time. And you're getting very small VMs, right? So if before you will run, 100 VM on a host, now you will run 100. Yeah. So what did we do? The stack look different right now, right? The only thing that you have is the hypervisor and the VM on top of it. Again, tiny VM, and each VM has your application. What we did, again, we just took what we don't need, move it aside. So this is kind of like a summary of the Unikernel. We'll click on it. So as I said, there is no other user. There is no multi-user support. That can be in your application. But to the machine itself, you cannot SSH. Right? It's a real immutable infrastructure, which means that if you want to rebuild your application, you're creating a new instance of it. So no permission check, giving us a real 100% utilization of your hardware. So that way you're getting better performance. There's no layer to abstract that need to translate, that need to do good performance here. Isolation only on the virtual hard drive, so you share only the hard drive, the hard drive, which is very important. In terms of size, if I will take today the regular VM, which is probably 1 gig of size, right? Ubuntu, the minimum Ubuntu that we take or something, it will be 1 gig. When we're talking about Unikernel, we're talking about meg, even K sometimes. So basically, the size of your application is the size of your Unikernel. So it's that small. Then, the boot time is very quick because there is nothing to boot. It's basically 2,000 lines or something like that. That's seriously, it's basically a bootloader that's loading. There's nothing to boot. It's so quick. And then the last thing is that it's a tiny surface of attack, but it's also custom, which means that if someone did somehow manage to expose it to one of my Unikernel, it's probably this script or whatever that it did in order to do that will not work for the other one because the library looks different, because everything looks different, right? So it's, again, not easy to penetrate Unikernel. So again, for your knowledge, there is two types of Unikernel today in the ecosystem. One of them is forward compatibility. That means that you have to write your application in a specific language. For instance, Mirage OS, which is the Unikernel that Docker bought of company Unikernel system here in the UK, actually, in Cambridge. You have to write in OCaml. So if your application is written in OCaml, you get a killer performance, but it has to be OCaml. Include OS, for instance, is a company in Oslo here. Again, very, very good Unikernel, but you need to do literally include OS because they wrote their own libraries. And that means that if you have a C++ application, you can run C++, but you need to run, you kind of like modify it a little bit. So again, there's others, you can look at them. Again, the advantage of that is that you're getting a better performance. If you're looking at the other type, it's what's called POSIX compliance. So POSIX is basically the API of the operating system. There is two that I see. Maybe there is more, but that's the main one. And the idea is that every application that you have today will run there if it's not forking, right? So we're running Go, Java, Ruby, Node.js, C++, just name it, everything, right? We can do it. We need to do it. OSV, it's another company. It's another Unikernel. It's kind of a Unikernel because they're adding a lot of stuff there that maybe kind of like sabotage the real philosophy of Unikernel, but they're very good with Java, so if someone running Java, it's probably will choose this one. But again, the idea is that you're not changing the application. You're giving them the Java or whatever, and it's going to work. This is an example, actually, of the company that's doing OSV. So OSV, by the way, were the guys who did KVM before, if someone knows. It's a company in Israel called Claudius. The beginning, they're focusing on doing Unikernel, and then what happened, they got scared a little bit from Docker, so they needed to pivot. And what they did, they decided to take Cassandra, rewrite it, and run it on Unikernel, and basically create like a killer Cassandra, much better performance. And they did it. So it's called ScalaDB, and the performance for that is 10 times better than the regular Cassandra. So if someone really wants to, kick his Cassandra, that's probably someone to explore. But I just want you to see here is that you can get a better performance with Unikernel, and this is a good benchmark to show that it's working. I don't know, am I on time? Yeah, we have time. So this is another two example that I like to show before we get into my project. The first one is the Pinata. So the guys from UK here, sorry guys. The guys from UK here created a Unikernel. And they basically said, you know what? We invited you guys to try to penetrate it. And there is some coin inside, and you will get it if you will manage to go. So go and try to basically act to it. And to be fair, it's there more than 2 years and no one managed to put it down. So this is an example of how secure is that. I heard from Include.OS that they're planning to basically put the Unikernel on their laptop and share it with the world to show how secure it is. It's basically a real sandbox, right? So that's one of them. The other one is this one. So again, it's just to show how good it is in terms of booting time. To spin up a Amazon EC2 is 300 seconds. To the time until, you can read it, lock the screen for Android, 450 seconds. And 0.2 seconds ago, they got a request from me when I clicked the button. They already spin up a Unikernel. This is the Unikernel. This is what we're seeing right now. It's a Unikernel. So just for you to understand, and if you think about how quick it is to boot, so think about the use case for serverless, for instance. Serverless is a serverless or function as a service. I don't know, there is a lot of Lambda in AWS. there's a lot of name to this, but basically the idea is that today the way it's implemented is the reusing container. That's interesting, but with Unikernel, you don't need to reuse because the boot time is so quick that you can actually just put a new one for each specific function. Okay, so let's go to the transition. Okay, so now we're going to talk about what we did. Any question, Dylan? No, that I can see or something? No? Okay. So what we did, okay? So when I looked at all this ecosystem, I said, wow, that's very interesting. If I am as an engineer or architect, it seems to me that this is the right architecture what we're running today. So the real question is why, there's not a lot of people who think like me. Why not everybody using it? And the best solution that I came with is that this is exactly the same scenario that container had before Docker make it easy to use, right? I mean, container was there forever, but we never used them because it was hard. Unikernel is even a little bit harder because you need to compile drivers, right? No one wanted to compile driver. So that's what we did. We basically did that for you. So what is Unik? Unik is basically a Docker-like tool to build Unikernel. So we're doing a little bit more than that because we're also deploying your Unikernel. But basically, it's the same thing. You're giving us your code, and I will explain in a sec. You're giving us your code. You're building an image. And then after it, you're just running the image. It's written in Go. It's open source. I will show you that. I mean, we open sourced it probably 4 months ago. And actually, there's, I don't know, we seriously have a community. Specifically in US, there is like over, I don't know, 900 stars. So, I mean, people digging into it. We have pull requests. It's looking very, very well. So how to use it, as I said, it's really, really simple. You want to build an image. The way to build an image is you're giving me the code, so you tell me where the code is. You're telling me which type of Unikernel you want, because I didn't want to choose that for you. We want to support every Unikernel that's out there, because it's a new ecosystem, and for everything there is use case. If your application is Camel, maybe you want to use Mirage. It makes sense. So we didn't want to choose that for you. The other thing that you need to give me is which language you're running. I want to compile, my code is written in Go. And the last thing, you need to tell me which provider you want to run on. And the reason is because I need to compile the driver for you. So I need to know if you're running on AWS, they're running Zen. I need to put Zen drivers. If you want to run on your laptop, VirtualBox, right? Different drivers. So I need you to tell me what you want. And that's it, and give me a name for the image. So now we created an image. Now you have this image, and now all you need to do is to run it. So Unik run, the instance name that you want to call it, and the name of the image that you created. Quite simple. So, for my opinion, this is the best, or the most important slide that I have in my talk. And it's the fact that Unik is not opinionated. And the reason we didn't want to make it opinionated because we don't know yet. It's a new ecosystem. There's a lot of use cases. We want you to be able to use everything. So what we did, we were very, very inspired by the Kubernetes architecture, where everything is kind of like a separate infrastructure and very, very nice. And if you look at the code of Unik, you can see that. It's really like the code is kind of like, look like a Kubernetes code. And what we did, we basically created 3 entities, if you like. The first one is Unikernel type. This is what we support today. So OSV mainly for the Java use case. I think people want to run Java as it is. It probably would be the easiest with OSV. Rump kernel, rump run, this is the one that I think that will win this ecosystem. The architecture is the best. It's basically coming from the NetBSD operating system. They re-architect all the NetBSD architecture to be very component-like. So now when it's component, they call it any kernel. And then what they did, they basically, now when you have that component, you can just pick and choose whatever you want. It's not like the Linux kernel, which is really, really messed up together. So now you can create basically a Unikernel. So the driver is the NetBSD driver, which means that for us, for instance, to add a support for something like Raspberry Pi, not that bad. You know why? Because there were already the drivers. Or for any other thing, because NetBSD is well supported. And also it's PaaS compliant, so you can run whatever language you want. So you will see Go, whatever you want. IncludeOS, actually, that's a pull request from the IncludeOS guy. They saw this tool. There was some publicity on it. They got excited. They said, oh, very interesting. But we don't see IncludeOS there, so they did a pull request. and they're maintaining that. And that's the unit type that we have right now. We actually have another one, Solo 5, but I will talk about it later. In terms of cloud provider, so I think it's almost everything besides Google that we are supporting for now. We probably will support that, just time. So again, it's an interface. The community can support it. Actually, the OpenStack one is a pull request that we got from Michelangelo, which is a project in UK, in Europe somewhere, that basically building the infrastructure. So they did this pull request. Before that, they were using OS3 and they forked it, and once they saw Project Unik, they said that's better because now it's basically an abstraction layer. We can use whatever Unikernel we want. So they added support for OpenStack. VirtualBox, if you want to run it on your machine, AWS, KVM again, for OpenStack or whatever. A QEMU, again, if you want to run it on your machine and you want to attach debugger, we're supporting that. VirtuStream, it's an EMC cloud. I'm working in EMC. vCenter, because it's mainly what is running out there. And Photon is, again, VMware Federation. Photon is the new technology for vCenter that VMware has, so we wanted to support that. And the last thing that I wanted to say is that if you're looking at the use case today, what I describe you right now in the cloud is very interesting, right? And I really believe that in the future, there are going to be use cases, full use cases for in the cloud. But I believe that right now it's a new ecosystem, and it's not really mature, and there is a chance that people will not, not all the tool will work, right? And so on. But I never met a person that told me that it's not a perfect use case for ARM. And here is why. For Internet of Things, sorry. And here is why. Why it's for Internet of Things. Because it's small. And you want small application on Internet of Things because, you're actually taking it with you. So it's better that it will not take much. It's very, very, the performance is crazy, which is what you want. And the last one, it's very secure. So this three, quality, I think it's like a perfect use case for Internet of Things. And that was very important to us, so we managed to make it work on ARM. Because we want we believe that that's the future of Internet of Things. So most of you probably know what Docker Hub is. The people who's running building the Unikernel are not specifically the one that will run it. And also we want to share it. So we created a Unik Hub. It's that simple, right? Like you can pull, you can push, and share it with others. In this example, we're running Minecraft, but okay, so now let's talk about the integration that we did. I think we did it right. Yeah, we need to get, okay. So I know that the community really, really liked Docker. And therefore, it was very important to me that you will not need to change all your tools. Because, if you wrote a script to deploy your Docker container, I don't want you to need to redo it for Unikernel. So what we did, we basically teach Unik to speak Docker API, which means that we use the -h flag. You can target a remote daemon. Now you can basically do the same thing with targeting a remote Unik, right? A Unik daemon, and basically just run it and it will work because it knows how to translate that. So that's the Docker integration. We're going to open source. It's already actually working. It's actually even open source, but we never announced that. We added support for Kubernetes. So Unik is like a Docker, right? In the end of the day, you're spinning up the Unikernel. We are not monitoring it. It's on you. And it's not cluster. And what you're asking for us, that's what we're doing, but it's on you to actually make sure that the state is the same. And when we looked around, we said, well, you know what? But that's what Kubernetes is doing, right? You can say that you want 4 instances of this unit Docker, and making sure that it's always what you're going to get, plus the load balance and other stuff that it's giving you. So we said, why to invent the wheel? Yes, let's create a runtime for that. So that's exactly what we did. So today, you can run actually, in Kubernetes, you can run a Docker container next to Unikernel, and that's just going to work. We open source it, it's there. I mean, I'm going to KubeCon, so I will talk about it there, I will show them and so on, but you can go actually look at it already. I'm also the CTO of EMC and EMC Dojo, so I needed to do something with Cloud Foundry, so we also integrated with Cloud Foundry. Again, kind of the same thing. The only thing is that the way Cloud Foundry is working, there is something that's called build pack, which means that this is how you compile the things. So that means that we didn't need to change anything in Cloud Foundry itself, so you can use whatever distro you want and just point it up, and to the right build pack. So we did that. It's open source. Again, you can go look, and I will show them. I will show them. So let's show them. First of all, any question? But I can see you, right? So either I was very clear or I lost you all. Okay. So just clear my screen. So I'm a SSH2 machine in Amazon. So what I'm going to do first is just show you that you're running Unik, and you have all, it's a very easy CMD, command line. And now what I'm going to show you is that if I'm doing Unik PaaS, I'm not running any Unikernel right now. I can do Unik images. And you see that I built some before. Oh, right. Right, yeah, sure. Better? Cool. So, as you see, I built some before. So let's spin up one to see how easy it will be. It will be as easy as do Unik. Actually, it would be easier just to do this. Unik, run. And actually, let's run this one. So this is a Minecraft. Let's just see if it will work. So I'm going to spin up a Minecraft. So now if I will do, watch, Unik, yes. So you see I'm already getting an address. So let's quit this. So now what I'm going to do is Unik PS just to see the IP address, and let's spin up a, probably was smart to do it before the presentation, but never mind. It was fun in Minecraft right now. One sec. So I'm going to spin up Minecraft, and what we're going to do, we're basically going to use the Unikernel. So we're going to add a server, call it Minecraft, and put the IP address 54.234.338.73. And done. And now we're just going to go there, and hopefully, and I'm playing Minecraft on Unikernel, right? Oops, I don't know how to play this game. So going, I'm jumping, I'm running, and I'm playing Minecraft. Okay? So that's the Unikernel. And again, we can actually look that the performance will be much better, it will be smaller, and so on. So let's just delete this for now. Now, oh, another cool thing that I wanted to show you, I shouldn't close it. I wanted to show you. So basically, Unik also is streaming the log back. So the way it's working Unik, we're actually putting a stub in order, so stub is a way to bootload the Unikernel, and we're basically streaming the log back to Unik. So all the logs is in Unik daemon, so you can actually do logs and see everything. So I just killed it, but basically you can see how I'm basically, I joined the game, I left the game, and the beauty of it is that you're getting all the logs, and when you're getting all the logs, I mean you're also getting the logs of the operating system itself, right? Because basically the way it's working, it's spinning up the operating system, and then spinning up your application, so you can see everything. You don't need to go to different logs in order to. Okay, so now we saw that. We can, I don't know, we can spin up another machine if we wanted to see how it's doing, like, for instance. We already see it. No, just an example for Node.js. No, you know what? Let's do right now Cloud Foundry. As you see, I'm very precise. So let's look right now at Cloud Foundry. So Cloud Foundry is a command line called CF, and you can look on the app. So as you see, I'm not running any app right now. What I'm going to do next is I will go to the directory that I have an application to run, a Spring application that I wrote. And what we're going to do right now, we're just going to spin up through Cloud Foundry. So it will be CF, so CF push. So we're basically pushing a Unikernel. What you can see is it's just using the build pack that we created, and it's open source. Okay, and we don't have a lot of time, so we'll do quick. So what you will see is that it's going as we create the Unikernel. While it's happening, I will tell you what we're going to do next. We're going to scale it, because that's what Cloud Foundry give us, and we will spin, I don't know, a 4 instance of the Unikernel. And that's what we're going to do. We're going to kill one, and I will show you how Cloud Foundry is bringing it back. That's simple, right? Just to show you that it's capable of doing what we say that it's capable of doing. Take a sec. And maybe while it's doing it, because we don't have a lot of time, let's go and finish the presentation, and then I will go back and I will show you. So I'm a big believer that it's our job to create the future and not stand aside and say, oh yeah, that's the future, trust me. So that's what we did. Basically, this is what you see right now. It's my engineer machine, Yuval. And basically what you see here is that we took a Raspberry Pi and we tried to put the Unikernel on top of it, and guess what? We got a black screen. It didn't even print anything. We couldn't even debug it, right? The operating system, anything, everything was dead. So what we did, we basically took another Raspberry Pi and put a GDB on it, that's what you can see here, and basically debug it, and then we make it works. Now, I don't have a time for here, and I didn't want it to bring the toaster, but you can go online and see me talking in different places, and what I'm doing usually here is I'm showing how Unik is making me a toast on stage. Just basically what we're doing is we're using U-boot, which is kind of like a pixie boot for Raspberry Pi. We loading the Unikernel on the bare metal, like on the embedded device itself, which is important, by the way, because there's other people putting an hypervisor or operating system. It's not as efficient. And basically then attach it to the toaster. I'm not going to show you that, but I'm going to talk a little bit about that, and then we will go back to show the demo because 4 minutes? Oh, okay. So, as I said, we added support for Mirage OS. Mirage OS is because they're Docker right now, they're quite a nice community. Again, OCaml is not my favorite language, but if people is using it, they should have an ability to build them very easily. Unik will give them this ability. Another very cool thing that is new in the ecosystem, and not a lot of people know about it, it's the notion of UKVM. So here is the thing. I'm building a Unikernel. I'm taking my application. I understand what I need to put inside of it, and I'm creating a VM. Now I want to run it. And I'm running it on an hypervisor. And what hypervisor is doing, they're mimicking all basically the backend for the drivers. So for instance, if my Unikernel doesn't need a floppy driver, it's still going to be mimicked by the hypervisor. And that's dangerous. So it's an IBM collaboration with Docker, all the ecosystem basically. What they did, they basically took KVM and modified it to be a Unikernel hypervisor, which means that when you're building your Unikernel, you're actually building also a little layer of hypervisor. And this is very important because now you can run on Linux, right? When you're building with Unik, usually you need to tell me where you want to run on because we don't want to put anything there that you don't need, right? If you're running on Linux on your machine, maybe it makes sense that you will be able to put it with the hypervisor. But if you will do the same thing in the cloud, you have a nested hypervisor. So again, there is philosophy argue here. But all I'm saying, this is very cool, and we are supporting it. So Solo 5 is Mirage OS running. So Mirage OS only running on Zen. Solo 5 is Mirage OS modified to run on KVM. And UKVM is the hypervisor. So we are supporting all of them in Unik today. So you can just take the code, OCaml, right? Because this is what you can run, and just run it and leverage from that. Suppose we're working on it right now. It's actually kind of done, but it's done, but we cannot open source it because of EMC, so stay tuned. I'm working on it. .NET support, think about it right now. Microsoft took actually .NET and make it work on NetBSD. That means to me that we can easily take it and run it on Unikernel. That means to me that you can run your .NET application with no license at all of Windows and no license of .NET, which is interesting. And you can bring all the ecosystem of, the Docker-like, because you can run whatever you want, to Windows, which the community is not like that yet, right? So that's an interesting thing. We're doing that as well. I think it will be interesting. I don't know. We'll see if Microsoft will not kill us before, but I think it's an interesting. More than this, I will say that because the way basically Unikernel is writing is built, there is the drivers and there is the application support. Okay, I'll finish in a sec. So basically now you can run C#, for instance, on Raspberry Pi, because basically right now a regular C# developer or whatever, if VB.NET can actually write an Internet of Things code, which I found interesting. Serverless, we talked about it a little bit before. I feel this is a perfect use case. NFV, it's even better use case because NFV, it's network function virtualization. There is a lot of demos, and again, I don't have the time to show you, that people spinning up a DHCP on request, getting the response, scaling it. and so on. So you can see Ericsson doing something like this. Again, that would be a very good use case. We open source. Go and look it. I don't have time, I'm sorry. But we open source. It's reading it Go, very, very simple. You can just go inside and go there and read it. And before you kick me out of the stage, we have a community. So come join, help us build it, right? Right now, it's me and my 2 engineers. That's not enough. We cannot stand it by himself. Come help us. People are already doing it. We have a Slack channel. Come ask questions. We have a Unik Twitter. It's going up constantly. We have a web, the GitHub itself. Come ask questions. And this is my people. They're amazing. Yuval, Kochavi, and Scott. And I didn't show you the demo. You can reach out to me. That's it. But I didn't show you the demo. Do we have time? You don't. Yeah. Sorry, guys. Okay.